Hi everybody, this video is going to talk through the 5.8 Ready, Set, Go notes, and these are in pages 21 to 22 in your yellow notes packet. So for today, our learning target is from 1A, and if you remember back to when we talked about the rubric, 1A is all about creating representations. And so that can mean creating graphs, which we've been doing a lot of. We can be creating equations or inequalities. And so in our case today, what we're going to be doing is creating an inequality given a graph. So we're kind of doing the reverse of what we have been doing for the last week or so. So over the last week, we were giving you an inequality and asking you to graph it, but now you're going to create the inequality if we're giving you a graph. And obviously, when we talk about inequalities, hopefully that should bring to your mind these symbols, right? Less than, greater than, less than or equal to, or greater than or equal to. So we're going to be using a graph that's given to us to write an inequality. That's the goal for today. So here's how we're going to go about it. We'll talk through some steps and then we'll do some actual problems. So the steps for writing a linear inequality. The first thing we're going to do is we're going to identify the slope and the y-intercept. And here we're going to say I don't want just of the line, we're going to say of the boundary line. And the reason why we want the slope and y-intercept, is because we're going to be writing these inequalities using slope-intercept form. So obviously it's going to be important to have the slope and the y-intercept. Now when we think about slope-intercept form, right, this is just a little reminder that slope-intercept form is going to be y equals mx plus b. So we're going to need our slope, which is the m, and the y-intercept, which is the b. So to find the slope from the graph, we're going to be using our old friend rise over run. And it's going to be really important here that we're careful with the sign. So if we have a line that we see is going uphill, it's important to remember that's going to be a positive slope. If we have a line that's going downhill, so we're going down and to the right, that's going to be a negative slope. The other piece we're going to need for our slope-intercept form is the y-intercept, or our b value. And remember, this is just where the line crosses the y-axis. So if we look at an example quickly that I'm just going to make up here, let's say our line looked like this. For this line, right, we know our y-intercept is going to be this point right here. So we would say that b equals 2. And in this case, just a quick comment, even though I don't know the exact slope, we know that this would have a negative slope because it's going downhill. All right, so once we've identified the slope and the y-intercept of our boundary line, we're going to determine whether the shaded area is above or below the boundary line. If our shading is above, we know our inequality must either be a greater than or a greater than or equal to. If it's below, we know the symbol must be less than or less than or equal to. And then finally, the last thing we have to consider is whether and again, I'm going to change this. I want to talk about whether the boundary line is solid or dotted. If we have a solid boundary line, our inequality must be either less than or equal to or greater than or equal to. And if it's dotted, it must be strictly less than or strictly greater than. So those are the pieces of information we need to ultimately write our inequality. So let's go ahead and look at a couple examples to see how this comes together. So problem 1, you can see I have to write the linear inequality for the given graph. And so here's how I would go about it. In step one, we said we're going to identify the slope and the y-intercept. I actually like to start with the y-intercept because that's a really easy point to identify. So I'm going to denote that with a B. And in this case, I can see it's right down here. Maybe use a different color so you can see it better. This bright green here, right? That's going to be our B. Use the same color. So our B is equal to -4, right? Because I'm kind of below the x-axis there. So now I know my B is -4. Now I have to figure out the slope, the rise over run. So the next thing I'm going to do is figure out the next kind of nice point that I see. And I notice here that the next nice point is this one right here at 1, -2. So in between those 2 points, I can see to get from my y-intercept to the next point, I have to go up 2. So that means for my slope, my m, it's a +2 over. Then I'm going to go right 1. So it's a +1. So we can just simplify our slope to 2. So now we've got a good start at getting the inequality for this graph, right? We know we are kind of using our slope-intercept form. So we have y. I don't want to write equals because we know this is not going to be equal, but we can do our mx plus b. Our m was 2, so we have 2x, and our b is a -4, so we have -4. So now our job, right, is to figure out, well, which symbol goes in between here. So that's really what steps 2 and 3 are about. So the next thing I have to do is decide, well, was this shaded above or below the boundary line? So sometimes what I like to do if it's not clear, it's probably pretty clear here, but if it's not, just pick a point and see, well, is the shading if you would look up or down? So if I pick this point, it's clear that all the shading happens down below. So it's shaded below, which tells me this must be either, let's make a note. Since it's shaded below, my symbol must either be less than or equal to. That's what we had written in step 2. So now the last thing we need to look at is step 3, determining whether the boundary line is solid or dotted. Well, in this case, our boundary line is clearly dotted, which means we can't have this option. It must be strictly less than. So with those 3 steps, we've written the inequality for this graph. It's y is less than 2x minus 4. So we'll do one more to make sure we're feeling pretty comfortable with this. And so I'm going to go in the same order here. So we said first we're going to start with our y-intercept. Well, in this case, it's this point right here. So I'm going to say my b, my y-intercept, is equal to 1. Next thing I have to do is find another nice point so I can figure out my slope, my directions here. So to get from my green point to my purple point, in this case, I have to go down 1. Well, for my slope, when I go down, that means I have a -1. From there, I'm going to go right 3. Since I went right, that's positive. So my slope is -1/3. And this makes sense. Remember up top, we said if my line was going downhill, I must have a negative slope. So we could double check ourselves to make sure our thinking is correct there. So I'm going to get kind of the base of our inequality here. I know I've got a y, and then my m, I've got -1/3 x, and my b is a +1. So again, the piece left is to figure out, well, what symbol is going to go there. So let's look at our shading here. In this case, you can see if I pick any line, or at any point on the line, excuse me, I need to look up to find the shading. So in this case, we're shaded above, which in step 2 tells me my symbol must be greater than or equal to. So what's going to help me decide is looking at the boundary line. Since this is solid, I have to have that kind of or equal to piece. So that tells me my symbol is going to be greater than or equal to. So our linear inequality for this graph is y is greater than or equal to -1/3 x plus 1. All right, now we just have one last piece to look at, and this is going to be specifically dealing with when we have boundary lines that are either vertical or horizontal lines. So let's quickly talk through this here. So the first thing in this case, we're going to determine, if and I'm always going to add this word boundary line, determine if the boundary line is vertical or horizontal. Remember, vertical lines, kind of like the vertebrae in your spine, go up and down. And their equation always looks like x equals. Horizontal lines, if you think of the horizon, let's see, sorry for moving that all over on you, looks like, looks like this. And their equation is y equals. So that's going to help us get a start to our inequality. We're going to know if we're dealing with an x or a y. Then we're going to, again, determine whether the shaded area, now this case is a little different. We have to think about whether the shaded area is either right or above, or left or below, right, the boundary line. And the reason we had to add in that left or right piece is if you think about a vertical line, right, I'm going to make one up here. Think about a vertical line, we can only either shade to the right or to the left. With a horizontal line, we think about shading above or below. But because of those vertical lines, we have to think about right and left as well. So right or above means we're looking for the symbol greater than or equal to. Left or below means I'm looking for less than or equal to. And then the last step is, again, to determine whether the boundary line is solid or dotted. Again, solid means I have to be either less than or equal to or greater than or equal to. Dotted means strictly less than or strictly greater than. So like we did before, we'll do 2 quick examples here, and then that will be it for today. All right, so here again, we've got a graph. We see some shading, so we know this is an inequality. So the first thing I'm going to check is whether I'm vertical or horizontal. Well, I can see my boundary line is like straight up and down, right? So that means I'm dealing with an x. I'm just going to put that right away. And I'm crossing the x-axis at 1. So that's kind of going to be my value here. Now again, I didn't put an equal sign because we don't have a line, we have an inequality. So the next thing I'm going to think about is where my shading is. Well, in this case, we're shaded to the left. So in step 2, that told me I must be either less than or equal to. And the last thing I check is the boundary line. In this case, I have a solid boundary line, which tells me I must be less than or equal to. And so that's how I'm going to finish off my inequality. My inequality is x is less than or equal to 1. For example 4 here, now I've got a horizontal line. Well, we said those are y, and it crosses the y-axis at 5. So that's the important value in my inequality. For this one, I'm shaded above, right? Horizontal lines, it's really easy to tell whether you're shaded above or below. Shaded above means I'm either greater than or equal to. And so then I check whether my line is dotted or solid. Well, here it's dotted, means I can't be greater than or equal to. I'm just strictly greater than. So the inequality that represents that graph is y is greater than 5. So with that, I'm going to end the video. Tomorrow in class, we'll do a quick warm-up to see how well we kind of understand this concept. And then as always, you'll have some practice to work with it. All right, thank you for your kind attention, and I will talk to you in class.